Hello students, welcome to lecture 15 of our online chemistry classes. In last class we started learning about the solubility product. We have solved some questions on it. I have given you one question as homework. I hope that we have completed that question. I will solve it once again for you so that you can verify the answers. The question was, determine the solubilities of silver chromate, barium chromate, ferric hydroxide, lead chloride and mercurous iodide at 298 Kelvin, and KSP values were given, and the question was, determine the molarities of individual ion. So first we will start with silver chromate, Ag2Cr4 in solid state plus aqueous, and we get 2Ag plus Cr4 minus 2 in aqueous state. The solubility is yes here. The solubility is 2s and yes. That's why KSP is equal to 2s square and s, which is nothing but 4s cube. They ask solubility, so we can write KSP by 4, cube root of that, cube root of KSP value for this silver chromate is given as 1.1 into 10 raised to minus 12 divided by 4. The cube root of 10 raised to minus 12 is, or we can write this as point s cube. In fact, we can calculate it. Let it be first s cube will calculate, and then we'll take cube root of that, because that's how I have answer is. So first we have to calculate s cube, which is nothing but KSP by 4. KSP value is already given, 1.1 into 10 raised to minus 12 divided by 4, and this comes to be 0.275 into 10 raised to minus 2, 1.1 divided by 4. You can do it by a simple calculator, which is nothing but 2.75 into 10 raised to minus 13. And if we calculate the cube root of that, how to calculate cube root of that? This cube root of 2.75 into 10 raised to minus 13. You can take this as 275 into 10 raised to minus 15. And 10 raised to minus 15 cube root is 10 raised to minus 5. And cube root of 275, we can calculate this as 6.5. So 6.5 is the 6.5 into 10 raised to minus 5 mole per liter is the solubility here. We can write Ag plus ion concentration, because they asked that also, which is nothing but 2s. And that's why 2 into 6.5 into 10 raised to minus 5, which is nothing but 13 into 10 raised to minus 5, 1.3 into 10 raised to minus 4 mole per liter. And what about the chromate ion concentration? Chromate ion concentration is nothing but solubility, which is nothing but 6.5 into 10 raised to minus 5 mole per liter. So see how we have solved this question. First we have seen this solubility product and solubility relationship. We have Ksp is equal to 4s cube. S cube is equal to Ksp by 4. Ksp was given divided by 4.275 into 10 raised to minus 12. 2.75 into 10 raised to minus 13 was the S cube. Then we calculate the cube root of that. S equal to 2.75 into 10 raised to minus 13 cube root of that, which is nothing but 275 into 10 raised to minus 15. Cube root of 10 raised to minus 15 is minus 15 by 3 minus 5. Cube root of 275 is 6.5. And then Ag plus ion concentration is 2 times of solubility. We have calculated. And chromate ion concentration is nothing but equal to solubility. That also we have calculated. So this was the first part of the question. The next part of the question is the barium chromate. So we continue with that barium chromate. In barium chromate, barium is divalent. So barium chromate in solid state plus aqueous Ba plus 2 CrO4 minus 2 aqueous, and we can say that this is yes, so this also yes, and this also yes. So Ksp is equal to S square, and that's why we can write S is equal to square root of Ksp, and that equals to Ksp value was given 1.2 into 10 raised to minus 10. 1.2 into 10 raised to minus 10. Square root of 10 raised to minus 10 is 10 raised to minus 5, and square root of 1.2 is 1.1, and then you can write mole per liter. So you can say molar concentration of Ba plus 2, which is equal to S, which is equal to 1.1 into 10 raised to minus 5 mole per liter, and molar concentration of chromate, which is equal to S, same value we are getting. So that's how this part B or part 2 of this question. Then comes the ferric hydroxide, part 3rd, ferric hydroxide. Ferric hydroxide Fe plus 3 aqueous, QOH negative aqueous. Yes, and it is 3s. Ksp is equal to S and 3s cube. That's why it is 27 S4. So S4 is nothing but Ksp by 27. What is the value of Ksp? They have given the Ksp value, solubility product value for ferric hydroxide as 1 into 10 raised to minus 38 by 27. We can write this as 100 into 10 raised to minus 14 by 27. S is equal to 4th root of 100 by 27 into 10 raised to minus 40. The fourth root of 10 raised to minus 40 is 10 raised to minus 10 divided by 4. Fourth root of 100 by 27 is 1.39, and this is mole per liter. Now once we know the value of S, we can write molar concentration of Fe plus 3 equal to S equal to 1.39 into 10 raised to minus 10 mole per liter, and molar concentration of OH negative ion is equal to 3S. 3 into 1.39 into 10 raised to minus 10, and that equals to 4.17 into 10 raised to minus 10 mole per liter. These are the answers for this ferric hydroxide question. Now regarding PbCl2, the fourth part of this question. There are 5 parts of this question, sub-questions. 3 we have completed. So fourth is PbCl2 is solid state plus aqueous medium, Pb plus 2, 2Cl minus. This is S and this is 2S. So Ksp is equal to S to S square, which is nothing but 4S cube, and that's why S cube is equal to Ksp by 4. Ksp for PbCl2 is given, which is 1.6 into 10 raised to minus 5 by 4. 16 into 10 raised to minus 6 by 4. 4 here. 4 into 10 raised to minus 6 is S cube. Then we have to calculate S. So it is cube root of 4 into 10 raised to minus 6. Cube root of 10 raised to minus 6 is 10 raised to minus 2. 6 by 3. And cube root of 4 is 1.59. 1.59. You can write capital M here. That's why you can say Pb plus 2 is same as S, which is equal to 1.59 to 10 raised to minus 2 m. And Cl negative ion concentration is 2S, which is equal to 2 into 1.59 into 10 raised to minus 2, and that equals to 3.18 into 10 raised to minus 2 mole per liter. This is the concentration of chloride. Right. So this is the fourth part of this question. Now fifth part of this question. Regarding the Hg2I2 mercurous iodide, Hg2I2 aqueous 2Hg plus or Hg2 plus 2 and 2 ions. That's how it get dissociated. It is S and this is 2S. That's why Ksp is equal to s 2s square 4s cube ksp by 4 s cube is equal to 4.5 into 10 raised to minus 29. This value is given by 4, which equals to 1.125 into 10 raised to minus 29. We can write this as 11.25 into 10 raised to minus 30 mole per liter. S is equal to cube root of 11.25 into 10 raised to minus 30. Cube root of 10 raised to minus 30 is 10 raised to minus 10. And cube root of 11.25 is 2.24 mole per liter. So you can say concentration of Hg2 plus 2 is equal to S, that equals to 2.24 into 10 raised to minus 10 mole per liter. But concentration of iodide ion is equal to 2S, 2 into 2.24 into 10 raised to minus 10, and that's why it is 4.48 into 10 raised to minus 10 mole per liter. So these are the questions which I have given you as the homework. I hope that you have completed these questions, because in all this type of question we have to all type of salt. The relation between S and KSP is very unique, and that we have to see in the particular salt, then only the problem can be solved. Right, so we'll go ahead and we'll see next type of questions now, because there are many questions in textbook exercise and textbook. We need to solve as many as possible. Calculate the solubility product of. Calculate the solubility product of A2X3, which is Al2SO4 twice like that, in pure water. KSP is equal to 1.1 into 10 raised to minus 23. So I have to dissociate this A2X3. It is 2A plus 3 and 3S minus 2. It is 2S and it is 3S. KSP is equal to 2S square and 3S cube. So it is 4S square, 27S cube, which is nothing but 108 S5. So this is how we can arrive at this relation. We can write S5 equals to KSP by 108. KSP value is 1.1 into 10 raised to minus 23 divided by 108. We can write this as 110 into 10 raised to minus 25. 108. This is nearly constant. So S5 is equal to fifth root of 10 raised to minus 25. 25 by 5 is 5. So it is roughly equals to 10 raised to minus 5 mole per liter is the solubility. 1 into 10 raised to minus 5 mole per liter is the solubility. Because this 25 divided by 5, if this cube root 25 divided by 3, if this fourth root 25 divided by 4, then that power I have to write here. You might have understood this by so many questions were solved till now. Now see the next one, because student feel only this type of questions difficult, but if you practice it, you will definitely have advantage. The value of KSP of the values of KSP of two sparingly soluble salts nickel hydroxide and AgCl are 2 into 10 raised to minus 15 and 6 into 10 raised to minus 17 respectively. Which salt is more soluble? So we have to calculate the solubility from solubility product, and then we have to decide which salt is more soluble. First we will consider this nickel hydroxide. Ni plus 2, 2H minus and 2S, S and 2S. So KSP is equal to S 2S square 4S cube. S cube is equal to KSP by 4. 2 into 10 raised to minus 15 by 4. This is 0.5 into 10 raised to minus 15. So we can calculate solubility here. For the solubility, we can convert this as 10 raised to minus 18. So this is minus 16, 17, 18. So that S is equal to cube root of 500 into 10 raised to minus 18. Now cube root of 10 raised to minus 18 is minus 6. And cube root of 500 is equal to 7.98. So this is for nickel hydroxide. Similarly, we can calculate the AgCl. AgCl aqueous state Cl minus aqueous state. This is S, this is S. KSP is equal to S square. Square root of KSP 6 into 10 raised to minus 17. We can write this as 6 into 10, 16 into 10 raised to minus 18. Minus 18 is minus 9. The square root of 60. Square root of 60 is 7.8. Two solubilities are before us. 7.8. 10 raised to minus 9 is lower solubility, and this is higher solubility. So we can say NiOH twice is more soluble. We can write solubility of AgCl is less than solubility of nickel hydroxide. Hence nickel hydroxide is more soluble. That should be our answer here. Now, after taking these questions, we'll see one last concept in the solubility product. And that concept is ionic product and solubility product relation. Here, if we take a solvent, say water, and if we add any salt, say NaCl, it go on dissolving into it, but it's when saturated solution is formed, it cannot dissolve more solute into it, and equilibrium is established. So you can say the KSP is nothing but molar concentration of Na plus ion and molar concentration of Cl minus ion at equilibrium. But we can calculate the ionic product of Na plus and Cl minus at any time. This is at equilibrium. The KSP concept is at equilibrium. And at any time, if we calculate the concentration, that will be the ionic product. IP means ionic product. It's just like we have reaction coefficient and equilibrium constant in the chemical equilibrium. We said when Kc is greater than Qc, reaction go to the forward direction. If they are equal, it is at equilibrium. And if Qc is greater than Kc, the reaction will take place in reverse direction. That's how we learn. Similarly, if Ksp is greater than ionic product is equal to Ksp, and ionic product is greater than solubility product. These three cases we will consider. When ionic product is equal to Ksp, that solution is called as saturated solution. Means its limit has been reached. For example, one classroom is there, and in that classroom say 50 students are sitting. Capacity is of 50 students. We'll consider three possibilities. In second possibility, we have 50 students. Capacity is 50 students and we have 50 students. It means it is saturated. But if we have 30 students, means ionic product is less than solubility product. It means it is unsaturated solution. Still we can add salt into it. Still we can add 20 students into classroom. If we have 70 students in the capacity of 50 students, we call this as supersaturated solution. It means more than capacity we added salt into it. What happens if ionic product is greater than solubility product? Precipitation occurs. Precipitation means the salt will remain as it is because its capacity of dissolving salt is exhausted. The capacity was only of 50 students. More we added, so it has been exhausted, and that's why the precipitation occurs. So, and if ionic product is less than solubility product, no precipitation. So question can be asked in the numerical form. They will give KSP and they will give ionic product, and they will ask whether precipitation occurs or not. If ionic product is less than solubility product, no precipitation. But ionic product is greater than solubility, precipitation. So we have to solve some questions related to this because exactly this is the concept. They will ask MCQs on it. So 2-3 questions on this concept are going to be solved so that the solubility product principle will be completed. So equal volumes of volumes of 0.002 molar solutions of sodium iodate and cupric chlorate are mixed together. Will it lead to precipitation of? Will it lead to precipitation of copper iodate KSP of copper iodate is equal to 7.4 into 10 raised to minus 8. Concentration of sodium iodate is 0.002 molar. Concentration of copper chlorate is also same. That's why we can say molar concentration of iodate ion is 0.002 molar, and concentration of Cu plus 2 is also same, because sodium iodide gives 1 mole of Na plus ion and copper chlorate gives 1 mole of cupric ion or Cu plus 2 ion. When equal volumes, because they said equal volumes of these solutions are mixed, new concentration, the iodide ion concentration becomes 0.002 divided by 2. It becomes half, because 1 liter, 2 liter we have, concentration becomes half, 0.001 mole per liter, and concentration of Cu plus 2 is also same, which is nothing but 0.001 mole per liter. Now we can calculate the ionic product of this. So ionic product is equal to molar concentration of Cu plus 2, copper iodate, and molar concentration of the iodide ion. As balance is 2, we can write it as square. copper concentration is 0.001. Iodide is also same, but square of it is 10 raised to minus 9. Ionic product is greater than KSP. 10 raised to minus 9 is greater than 7.4 into 10 raised to minus 18. We can write precipitation occurs. Should be our answer here. Precipitation takes place. Should be our answer here. See here, they are given the sodium iodide concentration 0.002 mole per liter. Cupric chloride Cu plus 2 and CO3 minus concentration 0.002 mole per liter. Equal volumes added, concentration becomes half. We added calculated the ionic product. Why we made it square? Because valency of copper is plus 2 and this is minus 1. So the formula of copper iodide. The formula of copper iodide is Cu IO3 2 times. That's why we made square of it. And Cu plus 2 concentration we know. Iodide also we know. Square of that. And we calculated concentration and we compared it. And then we concluded whether it is precipitation will occur or precipitation will not occur. What is the minimum volume? Or we will do first regarding precipitation only. See this question. This is a textbook exercise also. The concentration of sulfide ion. The concentration of sulfide ion in 0.1 molar HCl solution saturated with hydrogen sulfide is 1 into 10 raised to minus 19 mole per liter. If 10 milliliter of this solution, 10 milliliter of this is added to 5 milliliter of 0.04 molar solution of the following: FeSO4, MnCl2, ZnCl2 and cadmium Cl2. In which of these solution? In which of these solutions precipitation will take place? They are given table here, salt and KSP values. Salt is, we have FeS, Fe, SO4, MnCl2, zinc chloride, and cadmium chloride. No, they have given the sulfite FeS because they form sulfite and then hydrogen chloride form zinc sulfide and cadmium sulfide. It is 6.3 into 10 raised to minus 18. It is 2.5 into 10 raised to minus 13. 1.6 into 10 raised to minus 24. And 8 into 10 raised to minus 27. Now first thing we should mention here, precipitation will take place. Precipitation will takes place when ionic product is greater than solid product. We know that. Now we calculate the sulfide ion concentration. Before and after, M1V1 is equal to M2V2. M1 is 1 into 10 raised to minus 19. V1 is 10 milliliter. Next molarity we have to calculate. And it is added in 5 milliliter. This volume is 15. So we can calculate this molarity. And that happens to be 6.67 into 10 raised to minus 20 mole per liter. This is the sulfide ion concentration. Now we can say concentration of metal ions. On mixing will be concentration of Fe plus 2 equal to concentration of Mn plus 2 because all they are divergent. Zn plus 2 and Cd plus 2 is equal to 5 milliliter 0.04 divided by 15. 15 because 10 plus 5 milliliter solution. That equals to 1.33 into 10 raised to minus 2 mole per liter. Yes, we got this ion concentration and sulfide ion concentration. We have to multiply this now. We have right here ionic product of metal sulfide is equal to molar concentration of metal ion and molar concentration of sulfide ion. The molar concentration of this metal ion 1.33 into 10 raised to minus 2 and sulfide ion concentration we have calculated 6.67 into 10 raised to minus 20. If you multiply this 8.87 into 10 raised to minus 22, we have write mole per liter square. Compare this with the solubility product. We can say only sulfide and cadmium sulfide will precipitate as their ionic product is greater than solubility product. We have written values here. FeS is 6.3 into 10 raised to minus 18, which is smaller than which is greater than minus 22. MnS is 2.5 into 10 raised to minus 13. That is also not equal to ionic product. But zinc sulfide and cadmium sulfide, their solubility product is lower. How much? Zinc sulfide is 10 raised to minus 24, which is less than 10 raised to minus 22. And cadmium sulfide is 10 raised to minus 27, which is less than 10 raised to minus 22. And that's why it will be precipitated. So these are the questions from solubility product. In next class, we'll see some questions which will be helpful in solving MCQs of pH and pOH. And maybe next class we'll complete this equilibrium topic. So solve these questions once again. Read from notes and try to find out correlation between them. And then only you will have better command on the equilibrium, because equilibrium is very important topic. I have already told you the number of questions asked in the theory examination and MCQs are many more. So you should have very much command on these concepts. Thank you for watching this video.